Hey everyone! Welcome back to our channel. It's finally happened, the much anticipated fourth flight of SpaceX's Starship has taken place, silencing skeptics by achieving milestones beyond expectations. In today's video, we'll dive into all the details of this incredible launch and explain why it's more than just a rocket launch. Before we delve deeper, make sure to subscribe to our channel for the latest updates on the Starship and other groundbreaking achievements from SpaceX. The fourth test flight of SpaceX's Starship marks another critical step in developing the spacecraft designed for missions to the Moon, Mars, and beyond. This test flight focused on several key objectives, including launch, ascent, hypersonic return, and a soft splashdown. The countdown to the launch began early in the morning, with the launch window opening at 7 a.m. local Texas time. Preparations included propellant loading, with liquid methane and liquid oxygen being pumped into both the booster and the Starship. The final checks by the SpaceX flight director verified that everything was ready for the launch. As the countdown reached zero, the Raptor engines ignited, and the Starship lifted off from the launch pad at SpaceX's Starbase in Boca Chica, Texas. The ascent was smooth, demonstrating significant improvements in propulsion and stability. The vehicle passed through the maximum dynamic pressure, or max-Q, without issues, a critical point in any rocket launch where aerodynamic stress on the vehicle is at its peak. This phase had caused problems in previous flights. Interestingly, during this recent flight, the stage separation occurred as planned. The Super Heavy booster, equipped with 33 Raptor engines, completed its job and detached from the Starship. This phase was particularly noteworthy because the first flight of Starship had failed at this stage, with the vehicle disintegrating just 4 minutes into the flight due to the failure of the stage to separate properly. The vehicle's aerodynamic shell couldn't handle the combined forces of atmospheric pressure and internal stress from the engines, compromising the rocket's structural integrity and resulting in a catastrophic explosion. The second flight, however, managed to achieve stage separation but did not achieve its other mission goals. This time, the separation was successful, marking a significant improvement over earlier attempts. After stage separation, the Super Heavy booster performed a controlled descent. The booster aimed for a soft splashdown in the Gulf of Mexico, executing a landing burn to slow its descent. This marked an important step in SpaceX's goal of reusing the booster, although it still splashed down rather than being recovered on land. The Starship continued its journey on its own. It reached space and then began its controlled descent toward a planned splashdown in the Indian Ocean. This part of the mission was designed to test the vehicle's thermal protection system and structural integrity during the hypersonic return. In previous flights, particularly the third flight, the Starship had successfully reached space but disintegrated upon re-entry due to excessive heating and structural failures. For this flight, SpaceX had implemented several upgrades to address these issues, including improved filtration systems to prevent blockages that had previously led to engine failures. During its descent, the Starship faced intense heat and pressure. The upgraded thermal protection system was put to the test, and the data collected from this phase will be crucial for future missions. The vehicle's descent was carefully monitored, and engineers paid close attention to the behavior of the heat shields and other structural components. The flight plan included a controlled splashdown in the Indian Ocean. This was a significant change from the earlier flights, where the goal was often to achieve a dry landing. By aiming for a splashdown, SpaceX could gather data on how the vehicle behaves during a water landing, which is less complex and less risky for the uncrewed test flights. The only problem with this launch was one of Starship's flaps clearly suffering burn-through damage during descent. Live camera views showed the heat shield on the flap burning away, sending debris across the camera's view. This debris eventually led to the camera lens cracking, significantly hampering the visual feed of the descent. Elon Musk immediately took to Twitter to share his excitement with the world. He wrote, "Despite the loss of many tiles and a damaged flap, Starship made it all the way to a soft landing in the ocean. Congratulations SpaceX team on an epic achievement." In another tweet, Musk expressed his admiration for the material used in the Starship's construction, saying, "Stainless steel rocket." He elaborated further to make it clear why stainless steel was crucial for the success of the flight. He added, "Why is Starship made of stainless steel?" This article from 5 years ago explains the reasons. Worth noting that the ship would have failed on re-entry if made of aluminum or carbon fiber, as they can't take the heat. Stainless steel is highly resistant to heat, making it an excellent material for withstanding the extreme temperatures experienced during atmospheric re-entry. When a spacecraft re-enters Earth's atmosphere, it faces intense friction that generates immense heat. Materials like aluminum or carbon fiber, while strong and lightweight, cannot endure these high temperatures without significant degradation. Aluminum melts at around 660 degrees Celsius, and carbon fiber can degrade at temperatures exceeding 3000 degrees Celsius. In contrast, stainless steel remains stable at temperatures up to around 1400 degrees Celsius, making it far more suitable for the thermal stresses of re-entry. Moreover, stainless steel has excellent durability and strength-to-weight ratio. It can withstand the physical stresses of launch, space travel, and re-entry without compromising structural integrity. This robustness is essential for the repeated use of the Starship, aligning with SpaceX's goal of creating a fully reusable spacecraft. The choice of stainless steel also offers economic benefits. It is less expensive than other high-performance materials and easier to work with, which helps reduce manufacturing costs. This cost-effectiveness is crucial for the sustainability of frequent space missions. Musk finally tweeted again, "Today was a great day for humanity's future as a spacefaring civilization. Nothing unites us more than working together towards inspiring objectives." Comparing this flight to previous attempts, we see clear progress. The first flight ended in failure shortly after launch due to stage separation issues. The second flight saw improvements but still failed to achieve its objectives. The third flight made it to space and completed some mission goals, such as propellant transfer demonstrations, but failed during re-entry due to control issues. Each of these flights provided valuable data that informed the upgrades and adjustments made for the fourth flight. Following the success of the fourth test flight, Musk has shared an even grander vision for the future. He aims to launch 1,000 Starships per year as part of his long-term goal to establish a sustainable human presence on Mars. This plan involves building a fleet of Starships to ferry people and cargo between Earth and Mars, facilitating the development of a self-sustaining Martian city. Musk envisions setting up colonies on Mars within the next 20 years, with the eventual goal of creating a city of 1 million people. This vision includes launching fleets of Starships every 26 months, the optimal window when Earth and Mars are closest. To support this, SpaceX is rapidly increasing the production rate of Starships and building the necessary infrastructure, including super factories and launch sites. That's all for today's update. If you enjoyed watching and found it useful, please make sure to subscribe to our channel and hit the like button. Thanks for watching, and I'll see you in the next one.